Hey there, today we'll be doing this question that appeared in weekly contest 314. The question is 2435 parts in matrix whose sum is divisible by k. And this question is actually an extension of unique ways. So if you have not done this question, please do that one first. And this question will be an cakewalk for you if you do that question. So I'll be linking the question link also in the description. Please do check out from there. So coming on to the question statement, you are given a zero index time across an integer matrix grid and an integer k. We are starting from 0 comma 0 and we need to reach position m minus 1 n minus 1 by moving only down and right. This part is important, and we need to return the number of paths where the sum of elements on the path is divisible by k. Since the answer may be very large, we need to return it modulo 10 to the power 9 plus 7. So if you have done unique ways, this must be a cakewalk for you. Why? Because all you have to do is just count the number of ways till you are reaching here by just taking a sum variable. So this might have crossed your mind. Why not just take a sum variable, and that is absolutely fine. But there is one problem to that question. If you just take the sum, you will see that obviously we can do it in a 3D DP manner, but the sum can exceed. If you see, grid of ig's value is 100. Now, if grid of ig's value is 100, and if you see the constraints are pretty high, that is 10 to the power 4. So here we can have how many values, and here we could have how many values. So we could have 100 values here, and we could have 100 values here. So we can get 10 to the power 4 obviously. Now let's just say there is some worst case scenario. There are 100 values and all the 100 rows and 100 columns are filled by 100, right? So how will you actually take that DP state? So 100 into 100 and 100 into 100, that is somewhere around 10 to the power 4, and this also 10 to the power 4. So if you try to take a 3D DP of row and column, which we did in unique ways, that means I and j, it will obviously sum up to 10 to the power 4. But now you have also a sum variable to take care of, right? Sum variable, and the sum can go as far as more than 10 to the power 4, right? But you cannot have a 3D DP of size 10 to the power 8. That is impossible to take. It will give you an MLE, memory limit exceeded, obviously, right? So how do we actually state optimize this? Now we have to take care of this fact right here, that key is less than or equals to 50. That means we just care about all the elements that are divisible by less than equals to 50. So what we can do is that at every junction, whenever we are summing up all the values, that means 5 plus 2 plus 4 plus 5 plus 2, we will obviously be taking the modulo of each and every element. That means if we are taking this guy right here, what are we getting? Let's just dry run this for this example and you'll understand why we are doing it. Now the key given to us is 3 right here. Fine, we'll be taking every value modulo 3. Now how will this help us? Let's see. If we take this k modulo 5 modulo 3, what is the remainder? The remainder is nothing but 2. Now 2 modulo 3, the remainder will again be 2. Now 4 modulo 3, what will be the remainder? It will be 1. Now 5 modulo 3, the remainder will again be 2. And for this, remainder will again be 2. Now if you see, all the values that are present in your matrix now are compacted and shrinked to only less than or equals to 3. That means at most we can have a value which is 0, 1 and 2. It can never be greater than that, right? So if you just sum this up, 2 plus 2 is 4, 6, 8 and 9. It is still giving us 9, right? And 9 by 3 is what? It is divisible. That's about it, right? So that is the whole trick in this question. You just have to make sure that every state of sum, whenever you're doing it, just mod everything with k. Now if you mod everything with k, what is the k shrinking up to? Now if you see, the k right here was given to us as 50, right? Now the summation can at max go till where? It will obviously go till less than 50 only, right? Previously we were having a sum of greater than 10 to the power 4. We were having greater than 10 to the power 4. Why? Because we were not taking the mod. But let's just say in the worst case scenario, everything is 100 like this. Fine. Now 100 modulo 50 will be what? It will be nothing but 0. It will give you 0, right? So at the worst case scenario, we can have the summation, the third dp state, as 50. So what will be your dp state now? It will be I and j. I representing the row, j representing the column, and k representing the sum, right? K is representing your sum. And how much can k go up till? That is 50. And I and j can go up till how much? That is 10 to the power 4 into 5, obviously, which I had been ignoring, which should not be the case. And the k can go up till where? It can go up till 50, and which is well within our time limit range, and it will pass our solution. Fine. So I hope the explanation to this part up till here it's clear. Now let's get to the code and understand it better, how we have done it. Now I'll say again, please do check out the unique ways question, because the code is exactly similar, just exactly similar. All I have done is I've just added a extra dp state. That is, in unique ways we were having a 2d dp, here we are having a 3d dp. The only thing is one parameter extra is being added, nothing other than is different from that question. Okay, so coming on to the question, number of paths. Here we have declared at 3d dp as said. After that we are passing this to our function. Let's see what our function does. So this is the typical code that we write in unique ways. All we have done is we have carried the sum. At every instance, what are we doing? We are doing a mod with k, right? Up till here you must have thought about the solution. Obviously it is correct, but why was it failing? It was only failing because you have not done mod. So this took just I would say some time to me to figure this out, because I was pretty sure the code would work, but the only parameter that would fail is this. So all we had to take care was this modulo k, and this was the crux behind this problem. And I hope the whole problem is understood to you by now. And let's just run through this code once more. So this is the base condition. If we ever go out of the bounds, we will just return. If not, if we have reached the last stage, that means the last cell, what do? We just add our sum, whatever we have got, and mod it with k. If it is true, we just return a 1. If not, we return a false. And this is the typical memorization part that we do. And this is the part similar to unique ways. The only thing which we have added is this part. The sum is being taken as a parameter. At every step I'm saying that okay, I will maintain my sum, and at the end of the day when I reach the last cell, I will be checking if it is divisible by k. If yes, I will return a 1. And we are just storing everything in our dp table, and at the end of the day we are just returning it. And this is the whole code. And if you do need the code, please do check out the description, it will be linked there. And I hope this explanation was clear to you. If not, please do check the unique ways and then come to this question. You'll understand why I was saying all of these, and it will make sense to you perfectly. Okay. And I hope this is clear to you. And if you still have any doubt, please ask me in the comment. I'll be replying to you. And this is it for this video. And yeah, thank you for watching. Please do like and subscribe.